Today, we are going to dive into the world of big data. So, the talk today, I will introduce just some main concepts of big data. Then we'll write some code, and then we'll move to the large language model, and we do some analysis using large language model and big data. So first, you might ask, what is big data? So big data refers to the data set that are so large, so complex, that traditional data processing tools cannot handle them efficiently. So it is not, also you need to keep in your mind, it is not just about the amount of data, okay, but also about the challenge in storing, processing, and analyzing this kind of large data set. So that's the definition of big data. So now here there are 3 V's, 5 V's. So the first V, those are characteristics that define the big data. The first V is referred to the volume. So this is referred to the massive amount of data generated every second. So you can think about social media platforms. We are posting information or posting or tweets data every day. So we are generating data. There are some sensors everywhere in the airplanes and everywhere. With those sensors, they are generating data. So the model has changing. In the past, there are some companies, they generate data, but now we all generate data. So we are generating data every day. The Apple Watch or the watch, the smartwatch that you use, generate data. So this is V refers to the volume. And then the second part is the second V is velocity. So this is the speed at which new data is generated and needs to be processed. So for example, streaming data from IoT devices or real-time financial transactions require immediate processing. So this is the velocity. The data is coming, the data is generating in high speed. Also, the third V is variety. So data comes in different forms. So we have structured data, we have semi-structured data, and we have unstructured data. So this includes, for example, text, images, videos, audio, and more. So handling this variety requires flexible tools and techniques. So it is really hard. For example, if you think about, if we need to make the connection, you think about the volume. You might have 1 gigabyte of data, but this data is structured. So it is way different from 1 gigabyte of data, but the data is unstructured. So 1 giga of structured data is different from 1 giga of unstructured data. You might say the unstructured data, it needs some special tools to handle that data, like text or so on. The fourth V is veracity here. This refers to the trustworthiness and the accuracy of the data. So inaccurate or incomplete data can lead to incorrect insights. So ensuring data quality is important. And the fifth V here is the value. And I think it is it's explain itself. I will keep this for you. It is here, you can read this. So now here, so real world applications of the data. So for example, in healthcare, big data is used for personalized medicine and predictive analytics. For example, analyzing patient data to find treatment and predict health trends. In finance, for example, big data helps in fraud detection and risk management. By analyzing transaction patterns, we can identify fraudulent activity in real time. And that's the interesting part, okay? In retail, for example, here, big data enables customers' behavior analysis and targeted marketing. So stores can personalize offers based on purchase history and browsing patterns. And in manufacturing and also in smart city, big data can be used to solve many problems. So now we move to the second part of this lecture, which is Introduction to PySpark. So to process big data efficiently, we need powerful tools that can handle large-scale data processing. Traditional systems struggle with big data due to limitation in storage and computational power. But here, we need to use distributed systems. So distributed systems solve this problem by splitting the task across multiple machines working in parallel. That's the interesting part. So we have, instead of one machine process the data, we divide the data into tasks, we divide the data into chunks and the code into tasks, and we send those data and the code to different machines, and those machines, they can handle the data simultaneously and find the result. So Apache Hadoop was one of the first frameworks for distributed storage and processing using a technique is called map reduce, okay, model. So that's the main model to process distributed data or in Hadoop. However, Hadoop was good for some time, but has some issues. For example, if you look here, I put those issues here. For example, the disk input and output, Hadoop relies heavily on the reading and writing to disk, to the hard disk, which can be slow. So that's the main idea of Hadoop. So we have Hadoop Distributed File System, HDFS, and we have MapReduce, one for storing the data and one for processing the code in parallel. And but the main problem here that the data is stored into hard disk, and that's a problem with the input and output. And also that causes high latency, which, and for example, in batch processing, that's okay, but for real-time data processing, high latency is a problem. And also, I used to write code with MapReduce and Java. Writing MapReduce jobs can be complex and less intuitive. So it is not easy to write MapReduce work. So MapReduce code. So now this is where Apache Spark comes in. So Apache Spark is a powerful open source distributed computing framework. Okay, so it is just to process the data. That process data in memory, which makes it much faster than Hadoop for many tasks. So because Spark can process the data in memory, not in the hard disk, so that means we have low latency. And we don't have input-output as before issue when we read from the disk. So now that's interesting part about Spark. And today we are going to learn about PySpark, Py Spark. So this is just a Python API for Spark, because the Spark written in Scala. So I'm not expecting that you know about Scala. So that's why I decided to teach you about PySpark. So that's allow us to use Spark capability, but with Python. Okay, so we are not going to use Hadoop, we are not going to use MapReduce, and we are not going to use HDFS. We just focus on PySpark. Okay, so you might ask, is there any other big data tools? Yes, there are many. I teach this in my big data course at Wentworth. I teach this there's a graduate course named Big Data Systems. I teach all those tools, but today just I will visit them just to define them. For example, we have Apache Hive. This is a data warehouse infrastructure built on top of Hadoop for providing data summarization and query. And we have Apache Pig, a high-level platform for creating MapReduce programs used with Hadoop. And we have Apache HBase, a distributed scalable big data store. And we have Apache Flink, and we have Apache Storm. We have many. So I can Google here. I'm assuming that you can say big data ecosystem. And you can see that if I go to the image here, you can see that we have different tools. If you look here, you see that we have different big data systems. So today we are going to learn about Spark here, PySpark. But you see that we have big data system, a lot of big data tools. Let me see the ecosystem here. If you look here, you see that we have a lot of big data systems. But the main one is PySpark. If you really learn about how to use PySpark, it's really useful. If you can use it in your machine, if you have, for example, CPU or you have a CPU, and the use CPU, you have multi-cores, it can use all the cores. It is really different. So we are talking about here Spark. You see here Spark everywhere. So there are many tools, but the main one is Spark. So let us focus on Spark. So let me just, before I dive deep a little bit, how are you doing so far? Everything is okay, just to make sure that you are with me and everyone is enjoying his time or her time here. Everyone is okay. You hear me and everything is fine, just to make sure that you are here. In the chat window, you can say yes, you can write anything in the chat window. Good, thank you, thank you, thank you. That's great. Okay, good, thank you. I see many yeses, good, thank you so much. I see that. So, today, as I said, we will focus on the PySpark and how it simplifies working with big data. It is really, really, for me, I see it must tool. So simple to use, and you need to know about it. In 2024, you should be able to use that. It's not that hard. So, at the core of Spark is the concept of a resilient distributed dataset, RDD. So this is the main core of Spark. And what are the features of the RDD? RDD is just a data structure. It is more than a data structure, but it is, let us say a data structure, but a special data structure. Okay, so first of all, it is immutable. And this is so important to remember. So when the RDD is created, they cannot be changed. This ensures why they cannot be changed. This ensures consistency and makes it easier to recover from failures. This is one of the features. The second feature, the data is divided across different nodes in the cluster, allowing parallel processing. That's why we say it is partitioned. And also, if the node fails, RDD can recover lost data automatically. So that means it is fault tolerant. So those are the features. And let me show you online here. I'm visual. I like to show my student always things. So let us see RDDs Spark. And let us see, just to understand this more, you can see, I will try to find simple diagram. You see, this is RDD, this is an RDD. But let me see if I can see a simple diagram that help you to understand RDD. So I will go with this RDD Spark. I say immutable. For example, let us see here. So for example, here we have this an RDD, has all the numbers, but is distributed over different machines. 1, 2, 3, 4. The data is distributed. That's the main goal. You cannot, one machine and one core cannot handle your data. Because let's assume it is big data, 10 terabyte, 20 terabyte, I don't know. Very large data set, unstructured. So that's why when you see here, it is the RDD is a distributor. It is very interesting, data structure. And you can see here we have list of data. We can create an RDD, and each RDD has many partitions. You see here our data is partitioned. Yeah, for example, 1 and 2 in one machine, 3 and 4 on another machine, 5 and 6 and 7, 8. And can you imagine your data? 10 terabyte, 20 terabyte, some big data set. So that's the RDD. Always remember it is immutable. When you create this, you cannot change it. You need to create a copy of it. Okay. So now let us move to the next part. Now, those are the features of the RDD. Now we need to move to the operations on the RDD. The operations, we have two types of operations in the RDD. We have transformations and we have actions. So transformations create a new RDD from an existing one. So see the transformation process, we need this operation because you create a new RDD from the existing one. Why? Because the existing one cannot be changed. So that's how we do it. So it is immutable. So that's why we need to create a new one. And what are those transformation operation? We have map and filter, for example. Those are transformation. But keep in your mind they are lazy evaluated. So what does that mean? Meaning they don't compute the result right away. When you say map or you say filter, you don't compute the result right away. You have to wait until you call an action. So the action compute and return a result, such as collect, count, and they trigger the execution of the transformation. I hope that makes sense. So let us just go online and try to search for transformation and actions and see what we have there. Transformation, I just need to see transformation and actions. In Spark, for example, you see here we have different type of transformation. We have here narrow transformation like map, flat map, map partition, filter, sample. Those are just create a new RDD from existing one. Do you see? On the left-hand side, this is existing one, and the right-hand side, that's new one. So we create, each time you create. And we have wide transformation, like intersection, distinct, reduced by key, group by, join, and more. Those are problematic sometimes, because if you look here, we have shuffling, and shuffling is a problem. Okay, I don't need to dive there here because I teach this in one course, but just today to give you some idea about that. And yeah, I have material for one course. I teach course, an undergraduate course for big data, programming for big data, and that include all this stuff. But you need to know the transformation here. There are two types, and the wide one we really not. We try to avoid the wide one because they require shuffling. And can you imagine that you shuffle data between in the cluster of 4,000 nodes and with I don't know, a lot big data, so it takes time. Now for the action, and you see here in this diagram, you see that this is you create a new RDD each time. This transformation, you create a new RDD, and nothing will happen. They are lazy evaluate until you call the action. I will stop here. I don't need to dive deep, but to give you some idea. Okay. Now, this is the RDD, but the RDD is not. So we have more than RDD. This RDD was a low level. So when they built Spark, they built RDD first, but after that, the RDD, they create data frames. So while RDDs provide a lot of flexibility, working with them can be a low level. And sometimes it's not easy to work with them. It is okay. It's better than using MapReduce, okay? But sometimes you need high level abstraction over RDDs. You need something make it easy for you to use, okay? For example, similar to the tables and relational database or database frames and Panda. Do you know data frames in Panda? So that is so easy to work with them. So now here they create data frame. In Panda, it can work on one machine, but data frame here, it is just abstraction over the RDD and can work in multiple cores or multiple machines. And that also help the data frame is can help. They have something called Spark Catalyst Optimizer, and that can automatically optimize the query for better performance. And also we have support for SQL. So there are many benefits from using data frame. I use data frame all the time, but if I need to have more control over my data, I go and use RDDs. So if I go here online and show you, for example, the RDD versus data frame versus data set, we have three different data structures here. And you see that we have those data structures. We have RDDs. I hope I need to make sense for you because, as I said, I teach this in a long course over 15 weeks. But we have RDDs here, and we have data frame here, and we have data set. So do you see the images or not? I'm opening now images online. I'm opening the website Do you see let me see in the chat window. When I open, for example, now, what do you see now on the screen? You see that I open another website to show you the RDDs, the low-level RDDs, the data frame, and the data set. Is that right? That's what you see in the screen right now. Let me try to join and see what do you see there. Let me a second. Just to join from other machine to see what do you see here. So let me see. Give me a second. Yeah, you see it. Yeah, because I can see it here on the other machine. Good. Good. So if you have any question, please ask. So now you understand that we are going to work in PySpark, not Hadoop. We are going to work on RDDs and data frames, not data sets, because data sets only with Scala and Java, so they cannot be used in Python. And also, there's a transformation and there is action, and we talk about those, and we are going to use them. So let's move to the third part today, which is the coding part. Okay, so first of all, here, before we start the coding part, I would like to make sure that you have access to this link that I shared to you. Thank you. I see that you see that. Good. So let me share the link again and make sure that you can access this copy link. I know the introduction is not enough for big data, but that's the best I can do for 2 hours lecture. But as I said, I teach this over 15 weeks. So I give all the big data concepts in the first week and then dive deep into the code. So here, can you go to this link and download this notebook file? And then let's start. So the first thing here, we need to install PySpark. And also there's another library named FindSpark. This is used to set up our environment. So we need to install and use both of them. So that's how to install it. I'm assuming that you know Python. You see pip install PySpark, pip install FindSpark. I use a Q here to be quiet, so I don't need to see a lot of instructions here. You can remove this one if you would like. So this is the first thing you need to do. So I will slow down for a minute, give you time to download this and upload it. I'm sure that you know how to use Colab, Google Colab. You can upload this file to the Google Colab and you can run this cell. Okay, you install PySpark and install FindSpark. So, and we need this FindSpark from the name to FindSpark and install Spark. Okay. Just I will wait for 2 or 3 minutes just to make sure that you are able to download this. And please, in the chat window, can you confirm that you can download it? You can use, yeah, you can use that, I think. Yeah, you can use that if you know how to install PySpark, if you know how to use pip install, yes. It will be so easy for me and you because they have only 2 hours. You can use Jupyter Notebook. Yeah, you can do that. Or you can use Google Colab. It's up to you. You can use those. Yes, you can use Jupyter Notebook. I don't know how did you install that using an Anaconda or just use it, install it by itself. I'm not sure about that. As I said, I'm assuming that all this the configuration has done before me. Yeah, good. If you are using Anaconda, that's good. Great. But I prefer you to go and use Google Colab. So simple, so easy for you. It's way easier. If you have stable internet, you can do that. So I will give you 2 minutes here, please, in the chat window. Confirm that you have downloaded this notebook and you can use it either in VS Code or Jupyter Notebook, or you can use it in Google Colab. Either one, I'm fine with that. Google Colab is easier, but yeah, I give you 2 more minutes. Please, in the chat window, confirm that you downloaded this. Thank you. I see that. Yeah, please. Good, good. I will give you 2 more minutes to install that downloaded and yes, good, good. Great. Thanks so much for confirming that you downloaded this and you installed it. That's good. So let us see first at how can we use Spark. So, so, so what happened here, after you install Spark, here it is simple, just using this command pip install PySpark, and then you install find Spark. You need to import find Spark. I need to use, say, find spark.init just to do the configuration. I don't need to dive here. This is just to be able to use it in Colab. There, sometimes you need to do different ways. And now let us, then you from PySpark, you import Spark context. So Spark context is the entry point to Spark functionality. That's it. So it is the entry point. Let me make it simple in this way. So this is the entry point to Spark functionality. Okay. And also you need to import PySpark.SQL, import Spark session. And Spark session here is a single point of entry to interact with Spark data frames. So if you need to use data frames, you need Spark session. And you remember RDD, data frame, and data set. So we will use this with the RDDs, and we'll use this with data frames, if you remember. If you remember when I showed you this. So to use data frames, you need to import Spark session. I might show you a picture here, Spark session. First, Spark context, okay? And you can see different images here that might help you. I will go with this simple one and the first one. There are many. So if you see here, this is the Spark session. This is a unified API, but we have a Spark context. We have Spark context for core API. We have Spark context, streaming context. We have SQL context, and we have this Spark session. So there are different other pictures. They can show you different perspectives, but that's what I would like you to know today. Let me see, maybe this one can help more. Maybe this picture can help more here. Yeah, this is a video. We don't need videos. We need just pictures. Just they help us, some pictures. So we might see here this picture. We have Spark context, SQL context, and Spark session. So I like to use visual things to help. For example, here this one might help you more. So we have, this is the Spark components. We have Spark context here. And this is the drive program. That's what your program right now. This is the driver program, and you have Spark context. Is the entry point to the Spark workers and cluster manager and many more. So, and you can see here we have Spark context, and this is Spark context here, and we have many Spark sessions. So I think this is enough here just to give you an idea So we need Spark context and Spark session. So the first thing we need to do, we need to create Spark context, give it a name, for example, local here. And then this is local, and this we give it a name. I think here you can determine how many cores you can use, and if it is local or remote. So this is the Spark context. And also from the Spark session here, we can create this object Spark variable equals Spark session dot build dot app names. For example, we say flight data app dot get or create, and make sure that you run this once only. I cannot run it twice, because if I run it twice, I need to stop the Spark context and so on. So I think I need to run this one. Let me run. So this one, it works. I'm assuming it works right now. I run this. So run this cell only one. I'm assuming that you have this in the shared file. And now here, I need to import the data that we are going to use today. And this data is a flights.cl. So if I go to this link, I can show you the data online here. If you go to this link, I will download it using the code here, but if you click here, the data is in the GitHub, and this is the data, year, month, day of month, and you see that we have many information about the data. So, but what I'm going to do, I will run this cell here. So after you run the cell, you will download the data, flights.cl. So I'm assuming that you know Python. You know that is the URL, this is a variable, we import request, and from request, we get the URL. Then we open this flight.cps file as just write, and we just write file.write response.content. I'm assuming that you know this. I make this assumption because I know that you know about Python, you know how to download data from using. So we create this file, and as I said, if I double click, you can see the content of the file here. I think we can see that. It takes some time. This big file, maybe, I don't know. But if you, yes, see, we have the year, the month, the day of the month, and we have many information. The structured data, departure time. We have some other information, arrival time, and we have some other information. We need to use this file to do some analysis. So we download the data, then we need to use this Spark context SC. So you see the variable that we create here, we have SC, we create Spark context SC, and also we create Spark session Spark variable. So we have SC and Spark. We need to use those to do the analysis. So the first thing I will do, so from sc.text file, I read the text file that we download here. I read this file, that's it. So I read the file. That's so simple, using RDDs here. So we load and we create our first RDD. We create an RDD right now. We name it flights_RDD. Okay, then we can print the first 5 lines in the RDD. For example, here you see that we print the first one is the header. Then we have information here, 1, 2, 3, 4. So we print the first 5 rows of our data. Okay, but keep in your mind, your flight RDD, this is the type here. Let me try this. Let me try this one. So to give you some idea, I write type, and let us see what kind of object we have here. We have an RDD. So keep in your mind that you create an RDD. So that's the first. So let me close those. So the data, close this data, close this one. So we create an RDD right now. Then after that, let us here, in step number 4 here, we remove the header from the RDD. So what did we do here? We use this flight RDD.first. So let me show you the content of this first here. I will come here and I will create code. I will run this one. So this flight RDD, our object, that first, we return the first row, which we already know this is the header of our data. So we need to remove that header. How can we do that using RDD? So we get this data. and then we create a new RDD, and then we say flight RDD dot filter. So we filter this RDD. We use filter. Okay, we use filter, and we inside the filter here we use lambda, and for each line we go over the data line by line in the RDD. So while the line not equal the header, we need that data. So we know if it is equal the header, ignore it. So this will visit all the rows in your RDD and return all of them except the header. So I'm assuming also that you know what's lambda in Python. Okay, but now here lambda, you can write x, y, z. We name it the variable line. So go over each row in the data and return all of them except the header, this one. So we don't need the header. Okay, so now we have this RDD. If I print, let me run this code, and then let me print, for example, here I will say take, and I will print the first two lines, not everything. And you see now in the flight data, the new RDD here we create, the first line is not the header. We ignore the header. We only download. Now we have this. This is the first line because we ignore this one. That's how you filter the data using RDD. I know it is not easy to digest from the first time you see it, but the RDD, they need some time. I teach the RDD for maybe for 1 month to explain it in details to my students. Then we move to the data frames and data sets, but that's how it is. Now, there are many details. I don't need to dive deep in what's going on in the back end right now, but at least I go to the high view, I go to the general idea to give you what's going on. Now here, let us prepare, for example, the CSV data. So now I use this CSV function, and I use string IO just and create this Python function, parse to see if I said line. And then what did we do here? We use the function CSV.reader, and it assumes special data to be in special format as a file in the memory. That's why we are using string IO. And then we read the data, and we convert the data for the flight parset. We convert to another format. So let me print this here, .take 5. And you see that we convert the data to this format. So look for this data. Everything was in a string. You see the data here? Everything as a one string. The whole data set, every row is a string. Okay, but now what did we do using this way? We converted the CS file, so that means we have as a list of lists. Okay, it's still RDD, but we see that we have the number, we have here the numbers. Yes, they are still of type string, but at least we have each piece by itself. We converted each piece by itself. So that's what we did so far. So let me stop this one, and I will write, for example, just print type. I use type always because to know what kind of data I'm working with, I like to use type. So now let us see here. What do we have here? So the data, the RDD that we have here, we have an RDD. So we create an RDD. Then here we filter flight data originating from this airport. So here the AID, let us see which airport in this one. 1 second, let us see the name. I think Washington Dallas airport. Let us see what's the airport name. So this is Dallas International Airport. So now in our data, we have a column containing this information. So we only need to work with this data. So we go for filter flights parset, this RDD that we just create, flight parset, dot filter, and we go over, we go to the field number 16. So, and we only select the rows that belong to this airport AID. Let me go back and change this to the AID. Okay, and if I print those, you will see that this is the information. And if you go, this is the data right now. And if you go to number 16, you have 1, 0, 1, 2, 3, 4, 5, 6. Yeah, this is number 16. You see 16 here. In the 16 here, we have IAD. So what did we do here? We filter the data. We use filter function, and we use this lambda, and we go over each row in the data set in the parsed RDD, and we only go to the, we select the data when the fields number 16, the content of the field equal IED. We select that. Okay, and I showed you the data here. So now we are focusing on one airport, and now we need to extract and clean the departure delays. So let me share this. This is number 7 here. And the main goal here, I think we need to go up a little bit. I don't know if you mentioned that. The main goal of this code, the main goal here, we go to the top, is to calculate the average departure delay from the airport, Washington Dallas International Airport. So we need to calculate the average departure delay from the airport. And we are using RDD, but I want to show you how hard to use RDD. But this is beautiful, this is interesting. When you learn it, you like it. But you can use data frame and SQL and AI right now in so simple way. Just wait to see it. So now I gave you the hardest part, the RDD. We are doing the RDD. We filter the data, and we are trying to filter the data right now. And we are at point number 7 right now. But we will do the same task in one line of code. You will see it later. But let us learn about RDD. So with RDD, it takes time. So we now at step number 7 here. So what we are doing here, we need to extract and clean the departure delay. So, and also we need to handle missing or invalid values. So this is the code for that. For number 7, we run number 7 here. We run it. So let me share this code with you in the chat window, and you should be able, I will use the chat window to share the code. This is number 7 with everyone. Yes. So what did we do here? We define a function, get departure delay. We send the field. We use this try except or handle the error. What did we do here? We go to the field 15 and this data. And if field 15 is not missing, if it is missing, there's no value, we return 0. Else we convert the value to float because this is a string. If I go up here, I will show you here. If you see, for example, this is field 16. We are getting this data, and now it is a string. We convert it to a decimal or to the float, and we see here we read this, we convert to the string, and that's what we do. Sorry, to the float number. So that's what we did here. Okay, so now this is our RDD, and we can use map. And I showed you this transformation, and we create a new RDD. So we call the function. So when we use map, we call this function. So each row would be sent as a field to this, and we return the data back. So we get the delays here. I can print this value. Let us see. Delays. Yeah. So we see you have the Python RDD. Let me see here. There's a type. Let me say the take. Just a second. And what did we go? We get those values. 1, 2, 3, 4, 5. This is what we have. And we convert them to the decimal numbers. Okay. Now, I think the last step with the RDD, we need to calculate the average departure delay. We need to calculate the average departure delay from this using RDD transformation and actions. And this is the code to do that. Okay. We run the code and see the average. It is 7.7.07. That's the average. And what did we do? We go over this data frame, and we use reduce transformation. We are to say lambda x and y, and then x plus y. So let me show you how this works. It's so interesting to see how this works. To get the total departure delay. So if you look here, go to the image. That's how it works. Let me show you this one. This is how it works. So you see 1 plus 2, x and y. So 1 plus 2, then 2 is equal to 3. Then 3, the new value, plus this 3 equals 6. Then 6 plus 4. That's how it works. I hope that makes sense to you. So that's how it works using reduce in distributed way. And that's how we found. So it would be 0 plus 1, 1 plus minus 2, something like that. We have, okay, something. So then we have departure count. We need to get the number of rows. So this is the other function. Then we divide the total departure delay divided by the number flights, and we get the average. That's what we did. It looks like here using RDD is not fun. I like it. I use it all the time. If I need to get low level and with big data, with the PySpark. But you see, we have done a lot of steps. So I give you a time here, just to give you 2 minutes or 3 minutes just to finish this code. And let me share this code, the last one with you. So 1 second, let me share this code with you. So I think I share both codes with you that you need for different cells. So let me take you back here. So I shared this with you, both of them. You minimize this a little bit so you can see both of them. You can see this one and this one, both of them. I'll give you a minute. Then we'll move forward to data frame. It will be easier with the data frame. And then we'll move with the SQL. It will be so easy with the SQL. Then we'll use large language models and AI, and you see how simple it is. So give me just a second. Give you 2 minutes. I will mute for 2 minutes to finish this stuff. So please finish it. And you should get 707. When you get this one in the chat window, say I'm done. I got this value. Did you finish? Did you get this 707, the average delay, the average departure delay from this international airport? Good, great. So now, using data frame. If you remember from which picture I showed you here, this is the data frame. Let us use data frame. But you have, so we need to use data frame, but you should know that in the back end of the data frame, it is just high-level abstraction of the RDDs. Okay, so the first thing we need to do here in the data frame, we need to read data into data frame. How can we do that? It's so simple. So we see spark.read.csv file. And then we give the file name. This is the file we have. Okay. And then with the header, is it true? We see there's header there. So data frame will be created with the header. because we know there is a header on the data, and we say infer the schema. So Spark equal true. We don't need to do this by ourselves. We don't need to do this step to remove the header. We don't need to do that. We don't need to do this code to convert the data from one giant string, each row, to small pieces. We don't need to do that, to fields. We don't need to do that. This is just one option, just to make it true. It will be done for you. Okay, and also if there's a null value, so for example, this one here treats NA in the data as a null value in the data frame, and this one treats the NA in numerical column as none, or not a number. Okay, so interesting. There are a lot of things we write code for them. Just we wrote code above to handle them. Here, just one line of options. Just true or false or some configuration, make it easy. So let us read this data frame, and let me share this code with you to create the data frame. In the back end of the data frame, it is RDD. And yeah, if I create a new code here and say df dot show, and you see, wow, where is the data? So simple. We have the data as a data frame, as for example, same as the data frame in Panda or an Excel file, or maybe database, table database. So we read it. That's our data frame. But in the back end, there's an RDD. So this, it is a table, but it can, even if it is large data set, it can be run on multiple machines or multiple nodes or multiple cores. So we can process the data in multiple cores. So that's so simple, easy. The data is ready to analysis. Now, what should we do after that? So the second step here, we also can do something else. We can print the schema. So let us see here, data frame dot, for example, print schema. And you see that is the schema. And so interesting, the data, know this, the year of type integer. For example, this is integer, this is integer. So to convert the data to a right type. But if you look above in the RDD, all of them are string. We need to do a lot of manual stuff, manual configuration. But here with the RDD, with data frame, it's done automatically. Yes, it is not accurate 100%. Sometimes you need to modify it. That's fine. But in general, most of them, the schema can be inferred so easily using data frame. Okay, let me share this code with you. So I shared this one with you. Let me share both of those lines. Let me share those with you. Okay, so now here we need just to filter the data frame where original is the IAD, the airport. How can we do this? And that, so we can do this part here using this command. So if you look here, we, from PySpark to the SQL functions, we import average. This is a function. It is different from the average that with Python. This one can be distributed. Yeah, okay. You need to be careful when you use this average, and the average function comes with Python. But I think I don't know if there's average with Python, but there's min and max. They are different from the Python functions here. And we see data frame dot filter, data frame dot original equal this value. That's it. So you filter the data, only we pick this data when the origin is equal to this. Pick the rows when the origin is equal IDE. So you can see here we can pick the rows from this when the origin is equal ID. Where's the origin? Yes, you pick only those and ignore any other thing. You pick this one, you pick this one, and ignore the others. But how did we do this with the RDD? Look, how did we handle this with the RDD? That's what we did with the RDD. That's how we do that. We use filter, but we use lambda, and it is similar, not that difference here. There's no big difference. And then after that, we need to calculate the average departure delay using the aggregate function and display the result. That's it. So simple. So if we look here, I will run this and share the code with you. So we say we create this variable, average departure delay, and we say we use this data frame with aggregate function. We use the aggregate function, and we said, okay, we need the average of departure delay, and we change the name of the new field to the average departure delay, and we show the data we have. Now we get the result, we get what we want. So how many lines of code we read? Just one, this to filter, and this one to do the calculation. Way less than and easier than using RDD. So this, we get the same result, but in the back end there's an RDD. This is a high level abstraction. So we read the data, and then we do the filter. We select only one airport, and then we do the average. If you compare this code to what we did with the RDD, with the RDD, we did everything by ourselves. And by the way, as I said, there's an optimizer behind the data frame. So always use data frame, okay? Unless you need to do some stuff, interesting stuff. So you might go and use RDD, but I encourage you to use data frame. It's so simple. So now, if you are familiar with the SQL, you are coming from database background, as me. I used it as a database programmer for 10 years. I love SQL. So you can use SQL. It's so easy to use SQL. So how can we do that? Okay, so simple. First of all, you need to we need to register the data frame as a temporary SQL view, name it flights. How can we register? How can we do that? Register data frame temporary, as I said, as a view. You can say data frame. So you need to create your data frame first. Then you say create or replace temp view, and you name it flights. The name is important here because you need to use it later. That's it. So you create. So you can jump from here. You read the data. You have to read the data that we have it here, the table, and then you jump. You don't need to do this stuff. You register the data frame as a temporary view. Then you can write this code. Let me share both of them with you. Let me share this with you in the chat window. And let me share this code with you in the chat window. So we have it. So what happened here, look what did we do. We create a SQL statement, select average departure delay, and we change the name as average departure delay from the flight table where original equal IED. That's it. And then we say spark.sql, run this query, and we get the result and we show it. And let us do that. So it is one line code. One line code. So one line of code if here just to do this. And you can use, for example, this just another line to register. You can say 2 lines of code, maybe 3 lines of code. Just then, so it is easy to understand. You create a view, you write a SQL statement, and you run it, and you get the result. Done. Can you compare this, what we did here, with the RDD? Can you look here with the RDD? What we do with the RDD? We wrote a lot of code with the RDD. Okay? But sometimes you need to use RDD. Sometimes data frame, sometimes SQL. So if you can write this statement. So so we are done with this. So now there's an interesting part that I will mute myself for 4 minutes, just give you a chance. And please, if you have any questions, write them in the chat window. And then I will go to the 2024, 2023. How can we use large language models with PySpark and big data analysis? That's the final step, the final thing we need to do today. So I give you time just to digest this and write the code that I shared with you and run it in the Cowork Colab, and you should get the same result, 7.1. Okay. please in the chat window, let me know if you have any question or yeah. Good. Thanks so much. Great. Wonderful. So I showed you now just that you can do big data analysis using 3 ways. You can use RTD. You need more control over your data and you need to do everything manually. You can use this, what we did here. You can use RDD. I showed you how to read data using RDD. Okay, we use this Spark context .text file. And we did everything manually here, and you see the code. But why do I need to use RDD? I might use data frame, and we use data frame here. So simple to use data frame, and you do some configuration here to read your data as a table. Then you do some analysis, and also if you know SQL, you might convert your data registered as a data as a temporary view. And make sure that you name here. Do you see the flight's name? That's the flight here. For example, if you write XYZ here, you have to write XYZ here in the SQL statement. And then you can use SQL. And this is similar. If you like SQL, use SQL directly. Why you need to use RDD? Use just SQL and get the result. Okay. Now let me show you the most interesting part. So now here you see that Dr. Yetunde taught you about large language models, okay? And I don't need to dive deep here because she gave you a lot of information, and tomorrow she will give you more information. So now just we need to move to the next part of our lecture. So we need to discuss large language models, but not in detail. So large language models are advanced machine learning models trained in vast amount of text data. They can understand, they can generate and can manipulate the human language in a way that's really interesting. So we can use those tools to create chatbot, we can create content generation, and also in the code generation. And this is the most interesting part for us today. So we see that we are going to use Spark AI library. Okay, and let us see how. So if you go online here and you see what's Spark AI, this is the, I think this is the library Spark AI here. You see this is the library Spark AI. So and we can use this one. I will show you how to use it today, and with Spark. Okay. So this library, first let us install the library. Let me click here and install the library. So when pip install PySpark AI, and we install also OpenAI to work with OpenAI libraries and models like ChatGPT. So we install both of them, and you have this. Okay, let me have this code, and then here, if Spark is not installed, you need to install a Spark, and you might need to create Spark context and Spark session if needed. I don't need to run that. For me here, what did I do? I create secret here. This is my secret. key secret to OpenAI. I'm assuming that you know what's OpenAI and how to create API key. And let me try to read my API key. So that means here you need this OpenAI key. So I'm connected to the ChatGPT right now using this OS environment. I create environment, OpenAI API key, and I use this way because I have secret here. I create my OpenAI key. It is here, it is hidden. So now I can get that key and use it. So that means others, they can see it. They cannot see it. So now I'm using, I create this environment, open environment. Now let me, from PySpark AI, let me import Spark AI. And then I create an object, initialize Spark AI object with the Spark AI session. And then activate the Spark AI to enhance data frame capability. Let me run those two, and you have the code. So we now create this object, Spark AI, and we activate it. Now here, let us read the data, because it's our data here. We need to read the data, but now be careful, you need to use Spark underscore AI dot underscore Spark to treat CSV. So we read the data, and you have seen this before. Read.csv, if you remember, we did this here at the top. This is how we read our data inside the data frame here. Spark to treat.csv. We are doing the same thing, okay? But in different little bit with the Spark AI. So we read it here, we give this configuration, and we read the data. I think, did I click here? We need to read the data. And then the same question we need to answer. So look, what did we do here? This is the fun part. We say data frame, the one that we create here, .ai, .transform. So we use natural language to calculate the average departure delay from ID. So we get filter, flights, where original is IAD, and calculate the average of departure delay. That's in English language. Not RDD, not data frame, not SQL. They will be generated in the back end. But for you now, you can write English language. That's it. That's amazing. And then you run it. You will be connected to the ChatGPT, and you do the analysis. And what? See, look here. We get the same value. But we do nothing, just we write English language. Are you with me here, my students? Are you with me here? So, so do you see that? Everything is okay from your side? Do you see my screen and everything is okay? If you have any question, ask, please. Can you confirm that you can see my screen and all is okay? In the chat window, just one of you say hi. I can see the screen. People in the class there. The Newton, do you see? Newton, do you see my screen and all is fine? Yetunde. Good. There's a little delay. Yeah, good. So now I would like just you to notice this. Did you see the difference? Can you imagine this line of code? Compare this line of code with what we did here at the top. When we use RDD, do you see here, we use RDD, and we use all these code to answer the question, to calculate the average delay, departure delay. So here, just we write English language. So just in English language here.
So I know you wanted to wrap up your session. You wanted to wrap up this topic. So are you towards the end, or do you want to like have a break so that the dean?
No, I'm toward the end. I'm done. I am done. I gave them. This is the end here. We answered the same question using AI. The help of the AI. Just use natural language. Okay, and those are extra examples here for them to see how can they use natural language to answer different questions about this data. I would like them the next half an hour, if you can, if you have time, they try to answer those two tasks, task 1 and task 2. I give them 2 tasks here Just I would like them to answer those tasks using the 4 ways. They use RDD, data frame, SQL, and Spark AI. So if they can answer those questions, we have 2 tasks here for them. I think they should take 15 minutes to finish. So yeah, I'm done. Thanks so much, Dr. Yetunde, for this opportunity. And thank you all. If you have any question, I am here. I will answer them.
Thank you very much. Can we give it to Professor Othman? Yes, thank you very much for the